In this tutorial, you'll be creating and deploying a Terraform module to set up and configure an AWS S3 bucket for hosting a static website. This module serves as a comprehensive and standard solution for deploying static web content on Amazon S3. To begin, you'll write a Terraform script to establish an S3 bucket. This bucket becomes the repository for your website's files, such as HTML and CSS, with its name dynamically set using a variable. Moving on, you'll enable versioning for the S3 bucket. This feature is important for maintaining a historical record of your files, offering the flexibility to undo changes or recover lost data. The decision to enable versioning is controlled by a variable. The static website hosting configuration for the S3 bucket will be defined. You will utilize a variable, index document, to set the default index page for the website. Subsequently, you'll configure the public access settings. This step ensures your website is accessible to everyone. Following that, a policy granting public read access to objects in the S3 bucket will be defined. This policy enhances the visibility of your website's content. To optimize the execution order, the depends on attribute is employed. This ensures the S3 bucket policy is applied only after the public access block settings are fully configured, addressing potential access errors that may arise if the policy is applied prematurely. Additionally, outputs are defined to retrieve key information such as the S3 bucket ID, ARN, and the URL of the hosted website. Then you will incorporate the S3 website module into the root module. This setup modularizes the S3 website configuration, allowing for easy parameterization and reuse while providing specific values in a TFVars file for the desired configuration. Subsequently, you will create an outputs.tf file in the root module to consolidate outputs from different modules, providing a convenient way to access key information. This approach centralizes key information, making it easily accessible and providing a clear overview of important outputs from different parts of the Terraform configuration. Once everything is in place, you'll initialize the new module in your local Terraform environment. After initializing, you will commit and push the updated Terraform configuration to your GitHub repository. Then, you can observe as your automated setup kicks in, creating and configuring your S3 website infrastructure in AWS. By then combining AWS CLI commands with Terraform outputs, you will verify both the infrastructure state in AWS and the values you've exposed through Terraform outputs. This approach enhances confidence in the deployment process and ensures that your infrastructure is configured as intended. In the final task, you will integrate a GitHub Actions job for syncing your website files to the S3 bucket. This job runs after the Terraform job, indicating a dependency between the two. This setup automates the process of syncing your website files to the S3 bucket upon each push to the repository. Let's get started. If you haven't worked with your Terraform managed infrastructure in a while, or if other team members might have made changes, start with a Terraform refresh. cd into Terraform and then run Terraform refresh. This will update your local state file with the current status of your managed infrastructure. You can also check the current state of your resources to ensure everything is as expected. Using Terraform Show can provide insights into the current configuration and status of your resources. Create your third module directory using the mkdir command. This will be the module that setups and configures an AWS S3 bucket for hosting a static website. In the terminal, enter mkdir-p, modules, /S3, website. Move into the newly created directory using the cd command. Create the essential module files using the touch command. In the terminal, enter touch main.tf, touch variables.tf, touch outputs.tf. For a visual overview of your directory structure, run the tree command. This command displays the folder structure in a way that's easy to understand at a glance. It also helps you quickly see how files and directories are nested within each other. Enter tree // This runs the tree command in your Terraform directory. Your directory structure should look like this. Proceed by defining the necessary resources for the module. In the S3 website directory, open the main.tf file. Then, with a right-click, open the variables file, and select Open to the side. Close the Explorer panel. Close the terminal. And then adjust the dividing line between main.tf and variables.tf to optimize the workspace for your needs. Refer to the video description below, and open the link to the S3 website, main configuration reference file. You will find that the Terraform resource blocks required for configuring an AWS S3 bucket have already been compiled for you. These resource blocks are sourced from the Terraform registry. However, task at hand requires you to manually fill in the attributes for these resources, and define the variables and outputs. Copy the code to your clipboard, and proceed to paste it into the main.tf file. The code begins with the resource AWS S3 bucket, which indicates that the resource to be created is an S3 bucket. Name the resource website_bucket. This name is used to refer to this resource in other parts of your Terraform code. The bucket attribute specifies the name of the S3 bucket that you want to create or manage. Rather than hard-coding the bucket name, use a variable for flexibility. In variables.tf, declare a new variable. Type variable, and within double quotes, enter website_bucket. Then to define the variable structure, add a space, and curly braces. Back in main.tf, reference this variable in the bucket attribute. Type var, website_bucket. This links the bucket name to the value of your variable. The force destroy attribute, when set to true, allows Terraform to delete the bucket even if there are objects in it at the time of destruction. This can be particularly useful in development environments, but should be used with caution in production, as it can lead to data loss. In variables.tf, declare a new variable. Type variable, and within double quotes, enter force_destroy. Then add a space, and curly braces. Back in main.tf, reference this variable. Type var, force_destroy. Tags help organizing and identifying your AWS resources. For the name tag, inside double quotes type website bucket for, followed by the variable reference. Add a $, an open curly brace, var, period, website, underscore, bucket, close curly brace. This tag provides a clear identifier for the bucket's purpose. The next resource block is S3 bucket versioning. This specifies that you are managing the versioning configuration of an AWS S3 bucket. Versioning allows AWS S3 to keep multiple versions of an object, enabling recovery of previous versions if needed. Name this resource website _versioning. The bucket attribute specifies the S3 bucket to which the versioning configuration will apply. Instead of hard-coding the bucket name, reference the existing bucket by its ID for a dynamic configuration. You can do this by referring to the ID of S3 bucket, named website bucket, defined in the previous resource block. In this block, type AWS _S3 bucket. Period, website bucket. Period, ID. Now, define the versioning configuration block. In variables.tf, declare a new variable for this. Type variable, and within double quotes, enter versioning _enabled. Then add a space, and curly braces. Back in main.tf, reference this variable in the status attribute. Type var, period, versioning _enabled. The next resource block is the S3 bucket website configuration. This is used to configure an AWS S3 bucket as a static website. Name this resource website _config. This identifier allows you to reference the website configuration settings in your Terraform code. The bucket attribute defines which S3 bucket will be configured as a website. Instead of a static name, dynamically reference the bucket using its ID as you previously have. Next, define the index document block. This is important for setting up your S3 bucket as a website. Inside this block, define the suffix attribute. The suffix determines the default web page that S3 serves when a user accesses the root URL of your bucket. In variables.tf, declare a new variable for this. Type variable, and within double quotes, enter index _document. Then add a space, and curly braces. Back in main.tf, reference this variable in the suffix attribute. Type var, period, index _document. This is typically a parameter used in web server configurations. In most cases, this is a HTML file like index.html. Define the resource block for public access control on the S3 bucket. Name this resource website _bucket _allow _public _access. This name allows you to manage public access settings specifically for your website bucket in Terraform. The bucket attribute specifies the S3 bucket to which these public access settings will apply. Reference the bucket dynamically, as done previously, using its ID. The block public policy attribute controls whether public access policies are allowed on the bucket. It's common to set this to false when hosting a static website, as you may want to apply public read ACLs to allow users to access the website files. For a static website, block public policy is typically set to false to allow public bucket policies. This is especially relevant if you need to define a bucket policy that grants public read access to the website content. By setting Ignore Public ACLs to false, you respect public ACLs. If you have specific ACLs that grant public read access to your website files, you want S3 to honor them. Setting Restrict Public Buckets to false allows unrestricted public access to the bucket. This configuration allows public ACLs, public bucket policies, and unrestricted public access to the bucket, which is suitable for hosting a static website. The final step is to define a bucket policy for the website bucket. The purpose of this bucket policy is to explicitly allow public read access to all objects in the S3 bucket. This is commonly used when hosting a static website in an S3 bucket, as it allows users to retrieve the website content. Name this resource website_policy. The bucket attribute here also specifies the target S3 bucket. Reference the website bucket dynamically as you previously have. The policy attribute is where you specify the access permissions for the bucket. JSON encode is used to define the policy in JSON format. The version field refers to the version of the policy language syntax that you're using. This is the latest version of the AWS policy language. In the statement list, by allowing the S3 get object action, it enables file downloads from the bucket. The resource element specifies the objects or resources to which the policy applies. It defines the scope of the policy. You want the policy to apply to the website bucket. Start by typing an open square bracket, and double quotes right after the open bracket. Type a $, followed by an open curly brace. Now, you need to type the resource reference. Start with AWS_S3_bucket, then type a period. After the period, type website_bucket, which is the name of your S3 bucket resource in Terraform. Type another period, followed by ARN. This completes the reference to the ARN of your S3 bucket. Right after ARN, close the curly brace. Immediately after the close curly brace, without any spaces, type a / followed by an asterisk. This indicates that the policy applies to all objects within the specified S3 bucket. Then add a comma at the end of the line. In Terraform configurations, as well as in JSON objects, commas are used to separate items in a list. The principal element specifies the user, account, service, or other entity that is allowed or denied access to the website bucket. Here, type double quotes and an asterisk to allow public access. This setup allows anyone to retrieve files from the bucket. Depends on is an attribute used to create explicit dependencies between resources. It allows you to specify that one resource depends on another, ensuring that Terraform will create or modify the dependent resource. Here you can specify a dependency on the AWS S3 bucket public access block resource by referencing the resource like this. This ensures that the S3 bucket's public access settings are configured before applying the bucket policy. If Terraform applies the bucket policy before the AWS S3 bucket public access block resource is created, it might result in an access error. Adding depends on explicitly specifies the order of resource application, ensuring that Terraform processes resources in the desired sequence. After configuring your AWS S3 bucket with Terraform, it's important to output certain values for future reference or use in other parts of your Terraform code. Select variables.tf, and then open the Explorer panel. In the S3 website directory, open outputs.tf, and close the Explorer panel. First, create an output for the S3 bucket ID. The ID of the S3 bucket is a unique identifier for the bucket you created. To output this, add an output block to your Terraform configuration. Begin by typing output. Then, inside double quotes, name your output S3 _bucket _ID. Add curly braces to end the line, and press enter. On the new line, type description, followed by an equals sign. Then inside double quotes, type the ID of the S3 bucket. Press enter and type value, followed by an equals sign. For the value, reference the ID of your S3 bucket. Type AWS _S3 _bucket period. Website _bucket ID. Next, output the ARN of the S3 bucket. ARN, or Amazon Resource Name, is another unique identifier for your bucket. Follow the same steps. Type output, name it S3 _bucket, ARN, and add a description. For description, enter the ARN of the S3 bucket. For the value, type AWS _S3 _bucket period. Website _bucket period ARN. Proceed to output the URL of your S3 website. This URL is key for users to access the content in your bucket. Create an output block and name it website _URL. For the description, type the URL of the website. Next, you'll construct the S3 website URL in the value field. Start by typing double quotes, http followed by a colon, and 2 forward slashes. This sets up the standard HTTP protocol part of your website's URL. Now dynamically reference your S3 bucket. Type a $, then open a curly brace. Here enter AWS _S3 bucket. Period, website, bucket. Period, bucket. Close the curly brace. This snippet fetches the actual name of your S3 bucket. Next, type a period and then S3-website-. This pattern is unique to AWS S3's website hosting, and forms part of your bucket's domain structure. Now include the region. Type a $, open a curly brace, followed by var.region, then close the curly brace. This part ensures that the URL correctly reflects the AWS region where your bucket is hosted, as S3 website URLs are region-specific. Finally, complete the URL with period, amazonaws.com. This is the standard domain for AWS services, bringing your S3 website's full URL together. By completing this line, you construct the full URL needed to access your S3 bucket set up as a website. This approach of dynamically inserting your bucket's name and the AWS region into the URL ensures flexibility and accuracy. Using this output in Terraform makes it easy for anyone working with your configuration to retrieve the URL of the S3 bucket website after deployment. As you have referenced var.region in the output, you need to create the region variable. Switch back to variables.tf. Type variable space, double quotes, and region. Then append curly braces to the end. If you recall, var.region was previously defined in the root module, primarily for configuring the AWS provider. However, defining variables explicitly in each module is a good practice for clarity and reusability. It makes the module more self-contained and clearer to understand for anyone reviewing the code or using the module independently. In the next task, you will reference your S3 website module in the root module's main.tf. Doing so integrates the functionality of the S3 website module with your overall Terraform configuration. Select the main.tf window. Open the Explorer panel. And in the Terraform directory, open main.tf. Close the Explorer panel. Proceed to line 32, and begin by typing module. This keyword is used to define a module in Terraform. After module, add a space, and then name your module instance. Use double quotes and type S3_website. After the name, enter curly braces. This brace starts the block where you'll define the module's properties. Press enter and on a new line, type source followed by an equals sign. Source tells Terraform where to find the module's code. After the equals sign, type the path to your module. Add a space, use double quotes, and type period, /modules. /S3_website. Next, you need to declare and pass S3 website variables to the root module's main.tf. Even though the variables are defined within your S3 website module, you need to pass values to these variables from your root module to effectively utilize and customize the module. This is a fundamental aspect of how modules work in Terraform and is key to achieving modular, maintainable, and scalable infrastructure as code. On the right-hand side, select variables.tf, and copy the variables website bucket, force destroy, versioning enabled, and index document to your clipboard. Open the Explorer panel, and then in the Terraform directory open variables.tf. Close the Explorer panel, and paste the variables from your clipboard into the file. In main.tf, pass the website bucket variable. On the next line, type website _bucket, followed by equals. Then type var, website _bucket. Similarly, on the next line, pass the force destroy variable. Pass the versioning enabled variable. Pass the index document variable. And then finally pass the region variable. By following these steps, you're telling Terraform to incorporate and configure the S3 website module as part of your overall infrastructure defined in main.tf. To enhance the readability and visual organization of your Terraform code, you can align the equals signs within the modules section. For the DNS-ACM module, add spaces before the equals signs in source, root domain, and DNS record TTL to align them with those in the backend module. For the S3 website module, similarly, adjust the spaces before the equals signs to align with the above modules. To proceed, remove the comment line that reads configure the AWS provider. This will streamline your configuration file, making it cleaner and more focused on the essential declarations. In the next task, you will focus on enhancing the structure and organization of your Terraform code, specifically by managing output variables more effectively. Previously, you defined an IAM username output directly within your main Terraform file, main.tf. And within individual modules, like backend, DNS-ACM, and S3 website. While this works fine for smaller configurations, as your infrastructure grows, this approach can become disorganized. To address this, you'll undertake an important task, reorganizing these output variables into a dedicated file. Start by creating a new file, output.tf, in the Terraform directory. You can do this in the terminal using the touch command. This file will serve as a central location for all output variables that you want to expose from your Terraform configuration. By doing so, you enhance the clarity and maintainability of your code. Move the existing IAM username output from the main.tf file to output.tf. Cut the IAM username output block. Select the right-hand side window. Open the Explorer panel. Open the newly created outputs.tf in the Terraform directory, and close the Explorer panel. Paste the IAM username output block into outputs.tf. Next, enhance the clarity of your output. Add a description to the IAM username output. Enter the IAM user for Terraform. Proceed by copying the outputs from S3 website module. Open the outputs.tf file in your S3 website module. Copy the 3 outputs you want to include in your root module. Paste these outputs into the output.tf file in the root module. In the output.tf of the root module, you will now update the copied outputs to reference the S3 website module, like you did with the IAM username output. First, delete all S3 website values. For the S3 bucket ID output type module, which indicates you are accessing a Terraform module, then type a period, followed by the name assigned to your instance of the S3 website module in your root module. Then add a period, and type the output variable, S3, _bucket, _ID. Repeat these steps for S3 bucket ARN, and website URL. Now add the values for the S3 website variables to the terraform.tfvars file. This allows Terraform to automatically load these variables when it runs. Open the Explorer panel, open the terraform.tfvars file, and close the Explorer panel. To define a variable, simply type the variable name, followed by an equals sign, and then the desired value. First, define the variable for website bucket. The value for a website bucket variable typically is the name of the Amazon S3 bucket you want to create. Define the variable for force destroy by setting it to false. Terraform implements a safety mechanism to prevent accidental deletion of data. If there are objects in the S3 bucket, Terraform will prevent the destruction of the bucket to avoid unintentional data loss. Define the variable for index document. The value for the index document variable is usually the file name of the index document for your website hosted in an S3 bucket. Commonly, this is an HTML file named index.html. Define the variable for versioning enabled. When versioning is enabled, it provides a mechanism for tracking changes to objects over time, and it can be useful for scenarios where you need to maintain different versions of files or recover from accidental deletions. Ensure all the modified files are saved in your local workspace. In the top bar, choose File. And in the drop-down choose Save All. Now that you've created the S3 website module, the next step is to commit this change and push it to your GitHub repository. This will trigger the GitHub Actions workflow and deploy your module. However, running Terraform init in your local environment before pushing changes is a fundamental part of the Terraform workflow. Open your terminal and use the cd command to navigate to the Terraform directory. Execute the terraform init command. Running terraform init locally helps verify that your Terraform configuration is correct, and that all modules and providers can be loaded without issues. It's a good practice to catch potential problems early before they reach the CI/CD pipeline. It also ensures that your local environment matches what will be run in your pipeline. Next, use the git add command to stage all the changes you made for committing. Commit your changes with a message that describes what you've done. Type git commit-m and in double quotes type implemented S3 website module. Push your commit to the corresponding branch on GitHub. As soon as you push your changes, GitHub Actions will detect the change in your repository and start the workflow associated with the push event. You can monitor the progress of your GitHub Actions workflow directly in the GitHub repository under the Actions tab. This will show you real-time progress and logs of the workflow execution. When deploying AWS infrastructure using Terraform, you might encounter an access denied error during the first attempt. This is often due to the delay in IAM policy changes propagating across AWS services, affecting the application of S3 bucket policies. Rerunning the failed job provides a simple and effective way to address IAM policy propagation delays and successfully apply your bucket policy to your website bucket. Once the job completes, view the Terraform apply output to ensure that the IAM policies are applied successfully without encountering access denied errors. Upon the completion of deploying the S3 website module, verify the successful deployment of your AWS S3 bucket and its associated configurations. To facilitate this verification process, you can utilize the AWS command line interface. First, verify if your specified bucket is listed. Type AWS S3 ls. Next, verify if versioning is enabled. Type AWS S3 API get-bucket. -versioning. --bucket. Followed by your website bucket. Verify the website configuration. Type AWS S3 API get-bucket. -website. --bucket. Followed by your website bucket. Verify public access settings. Type AWS S3 API get-public. -access -block --bucket followed by your website bucket. Finally, verify that the bucket policy allowing S3 get object. Type AWS S3 API get -bucket -policy --bucket followed by your website bucket. These checks will help you ensure that your S3 bucket and its configurations are deployed and configured as specified in your Terraform code. You can also utilize the outputs from your Terraform configuration to further verify the setup of your AWS S3 resources. Type Terraform Output in your terminal to view the S3 bucket ID, ARN, and website URL. Check the generated URL for your website. Open the URL in a web browser. You will encounter a 404 not found error, which means the specified index document, index.html, is not present in the S3 bucket. To resolve this, you need to upload your website files, including the index.html file, to the root of the S3 bucket. You can do this using the AWS CLI by running the following command. Your website would then be accessible through the URL. However, you'd need to run this command whenever you make changes. Alternatively, you can streamline this by updating the deploy website workflow file. You can integrate the AWS S3 sync command or incorporate a GitHub action to initiate automation with each Git push. This ensures that any edits made to your website, upon commit and push, are synchronized with your website bucket. In the final task, you will update your GitHub Actions workflow. You will add the S3 sync action GitHub action, which efficiently syncs files to your AWS S3 bucket. You will set up a job named Sync S3 within your workflow. This job is designed to automate the uploading of your website's files to the S3 bucket, an essential part of deploying static content to AWS in your CI/CD pipeline. Open the deploy website YAML file in the GitHub Workflows directory. Then in the video description below, open the link to GitHub action to sync S3 bucket. This simple action was sourced from the GitHub Marketplace. Copy the job to your clipboard and paste it into line 43 of your workflow. Ensure the job is in line with Terraform. The needs keyword is used to define dependencies between jobs within a workflow. This means that before sync S3 runs, the Terraform job must complete successfully. Line 52 specifies additional arguments for the sync action. --delete ensures that files not present in the source are deleted in the destination. --exclude dsstore excludes files, which are metadata files created by the Mac OS operating systems, and are not needed. Line 55 sets the AWS access key ID using a GitHub secret. Line 56 also sets the AWS secret access key using a GitHub secret. Secrets provide a secure way to store sensitive information. These secrets were added to your repository in Part 2 of the project. Line 57 sets the name of the S3 bucket directly. Here, enter the name of your website bucket. Line 58 sets the AWS region. Enter US-East 1. And finally, line 59 specifies the source directory from which files should be synced. In this case, it's set it to website, located at the root of your repository. Save the changes to your file. To proceed, commit and push these changes to your GitHub repository. Open the terminal, and confirm that you are in the root directory of your project. Stage the changes for commit using git add. Commit the changes with a descriptive message, such as implemented S3 sync GitHub action to workflow. Push the committed changes to your GitHub repository. Open your web browser and go to your GitHub repository. In the Actions tab, you should see a new workflow run triggered by your recent push. Click on the workflow run to view detailed information. Check your AWS S3 bucket to ensure that the files are synchronized as expected. You can use the CLI for this. Enter AWS S3 ls S3:// followed by your bucket name. You can also visit the website URL to ensure it's accessible and functional.